Welcome to our practical on force and extension. We're going to look how force can affect extension on a spring. We're going to look into the limit of proportionality, and we're going to experiment with Hooke's law. So the equipment we're going to be using is a meter ruler, stand, clamp, G-clamp, some bosses, some more clamps, a real spring, masses and a splint to help us with our accuracy. We're going to set this up now quite simply, putting our stand on the end and our G-clamp. Now this is really important to get the zero when the spring is not extended, so it's a 0, 0 intercept from that. One important piece of equipment is the safety goggles. I really need these on in case that spring there goes past its limit of proportionality and we get a snap spring which could hit me in the eye. Okay, so I'm going to start by taking all the masses off. So the first part is the independent variable. The thing that I'm going to change is the mass, which creates a force of around 1 Newton pulling down on this spring. So if we can have a look now, you can see that that will pull down on there and take my splint down to a certain level. I can get down and see. What I need to do now really is make a table for these results. So we're going to look at the force in newtons, and that is the independent variable on the left, which will start at 0, and I'm not going to take it any further than 4 newtons. On the right hand side, this is now going to be the dependent variable, the thing that I am measuring, and this is the extension. I'm going to do that in centimetres. So at 0 we had 0 extension because the spring had no force on it, and as soon as I put 1 Newton, which is roughly 100 grams, we had 4.1 centimetres. So now I'm going to take measurements for each one of my forces and record them as we go. So our control variable for this experiment is evidently the spring, because we don't want to change the spring because it'll have a different constant if it's a different spring. So not forgetting to lower that weight gently so it doesn't spring down and overextend the spring. I'll start my graph with a title, Force and Extension Experiment. That's what I'm going to title it. I'm going to look at a scale for my Y and X axis. There's my Y axis going down and my X axis will be going across. I'm looking at a scale that's suitable to match that dependent variable up the Y scale there and across this X axis here for the independent variable that I changed. It's easy to get a independent variable scale because it's just 1, 2, 3, 4, and I'm going up to 20 centimeters on my dependent side so I can measure it up to the maximum value. I'm beginning to plot this graph. I'm going to plot this as a scatter graph, and you'll notice that it'll start to make a line, and I'm going to draw a line of best fit once I've got all 4 points in place. Don't forget, a line of best fit goes for as many points as possible. So using the equation of spring constant equals force divided by extension, I can work out the actual spring constant of this small spring that I've used in the experiment. I'll then use the reading from the x-axis of 4 newtons, go across to the y-axis 17.5 centimetres. I need to convert that to put it into the equation of 4 divided by 0.175 metres, which gives me a spring constant of 22.86. So if you want any more videos like this, just don't forget to give us a like and subscribe. Thanks to my Year 10s for helping me with this in their GCSE required practical. Don't forget, revise, prepare for those exams, give it your best.